All right, time to introduce a new concept. Finally, right? Enough of beating the dead horse about marginal physical product. So we're going to actually introduce average physical product curve. And what the average physical product curve is, or the APP curve, or the APP, is the level of output relative to the level of input. Basically, we're going to find the average of output per input. So anytime you want to find the average, you take the total of one divided by the total of another, right? So your average grade is you add up all of your grades divided by the total points type deal, and you can find your average grade. Or the average across, say, 4 different tests, where you take up all the points from the 4 tests divided by the 4 tests, and then you can find the average test grade. So your test grades are your output, the number of tests are the input. So we're going to find the average test grade, or the average APP for across the 4 tests. We take the test grades, add them up, the total output divided by the total input. So to find the average, we're always going to take the total output divided by the total input. So we go ahead and do that down here. And as you can see, that we've already done that right here down here on this table. So if we take total output divided by total input, so 1 divided by 10, 0.10. We take 3 divided by 16 is 0.19. 4.8 divided by 20 gives you 0.24. So just like I encouraged you in the last video to calculate and do examples of this marginal physical product, make sure you get these numbers and actually do the calculations yourself. Go ahead and take some time and calculate this average physical product, and make sure that you get the same number, so that way you know how to calculate average physical product. But it's just simply output divided by input. So we go ahead and calculate this average physical product, and we get this red line down here. And this red line shows us what is the average amount of output per unit of input. So it has a very important relationship to the marginal physical product curve. And we're actually going to put the marginal physical product and the average physical product curve together. And we're going to come up with 3 different stages of production. So don't get this confused with the 3 stages of the marginal physical product curve, where stage 1 was up until the peak, stage 2 was up until it hit 0, and then stage 3 was negative when MPP was negative. These are 2 different concepts. We're going to talk about the stages of production. So there are 3 main stages of production. So we know that there's an important relationship between marginal physical product and average physical product. If marginal physical product is above average physical product, so in this case, we know that marginal physical product is actually above that average physical product. We can see that right there on the graph. We know that average physical product is actually rising. So let's look down here at our table. So marginal physical product is greater than average physical product here on this line. So we know that average physical product has to increase, and it does. So here, marginal physical product is above average physical product again, so we know average physical product is increasing. So we keep looking at that, and lo and behold, as long as marginal physical product is above average physical product, it is continuously decreasing. But then we get to this point where marginal physical product is less than average physical product, and we see average physical product actually begin to decrease. So average physical product, it's going to tell us how much output can we get per unit. So we talked about marginal physical product, as long as it's increasing, is going to show us the efficiency of an additional unit of labor, or an additional unit of that input, where average physical product is going to show us the overall efficiency of that input. So as long as average physical product is increasing, the overall efficiency on a per unit basis, the overall efficiency is actually increasing. And what I mean by that is, by using, say, 16 hours of labor, we can get 0.19 units accomplished per hour. And then if we increase to 20 hours of labor, we can actually produce 0.24 units per hour. Well, 0.24 is greater than 0.19. And actually 0.3 is greater than 0.24. And 0.131 is greater than 0.30. On a per hour basis, we can get more done, which means we're actually more efficient up until this point. This point right here is going to show us the peak in efficiency in terms of the amount of inputs we should use. This level of input at 26 hours, we are going to be able to accomplish more per hour than anywhere else. Now notice I'm saying per hour, not per additional hour. Per additional hour deals with the marginal physical product. Per hour, the per total hour is average physical product. So we're actually going to get the most done at this level on a per hour basis. So let's go ahead and talk about stage 1, stage 2, and stage 3. So stage 1 is where marginal physical product is above average physical product curve. So remember, if it's above the average physical product curve, the average physical product is increasing. So as long as marginal physical product is greater than average physical product, we can actually see that efficiency per hour is going to be increasing. So our efficiency per hour for this production unit, or for this scenario, for a hypothetical company called TopAg, they're actually going to become more efficient on a per unit of input basis. So it's actually at the end of stage 1 that this company is going to be the absolute most efficient. That's where this 0.31 is going to occur. So efficiency on a per unit basis is increasing in stage 1. Then we get into stage 2. Stage 2 is where marginal physical product is actually below or less than average physical product curve. We can see that that marginal physical product curve is actually below the average physical product curve. So what is that going to do to our efficiency? Well, our efficiency is beginning on a per unit basis is beginning to fall. So in stage 2, we're actually losing efficiency. But if you remember, if we were to put on the total physical product in stage 2, total physical product is still increasing. We know it's still increasing because marginal physical product is still above 0. So the key thing where in stage 2 is total physical product is still increasing, but our efficiency on a per unit basis is beginning to fall, or is falling in stage 2. Now in stage 3, marginal physical product is actually negative. That's where total physical product is actually is beginning to trail off, is beginning to fall. And we're going to see that actually average physical product continues to decrease unto that point. So I've got a challenge for you. I want you to actually take these daily labor use, put it into a table and this daily output, and I want you to calculate marginal physical product. I want you to calculate average physical product, and I want you to try and see if you can graph all three on the same table, or at the very least grab marginal physical product on one table and average physical product on, or graph marginal and average physical product together, and really start to dive into these numbers and see if you can get the same numbers and draw out these graphs yourself and see how they are actually working. And as you graph this average physical product, remember that labor use is still down here. Our inputs are still on the horizontal axis, but now we're graphing marginal physical product and average physical product over here on this vertical axis to show this graph. That gives us stage 1, stage 2, and stage 3. Now remember, this is stage 1 of production, stage 2 of production, and stage 3 of production. It's not still the same stages of marginal physical product, but it's the stages of production that we're dealing with in this slide. And we find those by comparing the average physical product to the marginal physical product curve.